Hello, in this video we are going to do an example where we find the equivalent resistance of a combination of resistors that are connected in both series and parallel. The goal here is to take this combination of three resistors and replace it with one resistor which has the equivalent resistance of the original three resistors combined. This means that if we were to hook up the original three resistor combination, shown on the left-hand side of your screen, to a battery, then those resistors would draw a certain current from the battery and dissipate a certain total amount of power. If I were to replace all the resistors with one equivalent resistor, Req, I've shown that on the right side of the screen, and hooked it up to the same battery, we would still end up drawing the same current and dissipating the same amount of power as the original circuit. If you've watched any of my other videos, some of them have examples where the resistors were all hooked up in series or all hooked up in parallel. Now, we're going to do something a bit different here because you can see that this setup contains both series and parallel connections. When we do these type of questions, it is important that you do not try and combine all the resistors in one step. So take some extra time to combine the resistors in multiple steps. In general, I tend to combine no more than two resistors in a single step. It does take a little bit longer to do the problem, but it is worth it for a couple of reasons. One reason is that dealing with two resistors at a time helps prevent you from making any mathematical errors when combining resistors. The less numbers you're working with for a calculation, the better. A second reason is in later problems when we're performing a full circuit analysis where we have to find currents, voltages, powers, you will find that having written down these multiple steps will help you tremendously. All right, let's get back to the question at hand. In the original circuit, you should be able to see here that R2 and R3 are connected in parallel because the current can separate into two different paths. Part of it can go through R2 and the rest of it goes through R3. So that means they are in parallel. So for my first step, I want to replace those two resistors with an equivalent resistance, and I'm just going to call it RA. To find RA, I can use the mathematics of combining parallel resistors. I can find that RA equals 1 over R2 plus 1 over R3, and then you put all of that to the power of -1. When I actually use the values, I'm going to use 1 over 2 ohms plus 1 over 3 ohms. I'm going to take that all to the power of -1. You may want to pause the video and try the calculation for yourself. It turns out that if you've done correctly, RA is 1.2 ohms. Now, one thing to watch out for, and I'm just going to mention it briefly here and then erase it, is that the most common error that people make when combining resistors in parallel comes from that power of -1. If I gave this combination of resistors to a group of people and asked them to calculate, I would get a lot of students reporting that RA is 0.833333 ohms. But that value of 0.8333 so on ohms happens because the students will do 1 over 2 ohms plus 1 over 3 ohms. That gives you the 0.833. But then you need to take this value to the power of -1 or take the inverse of it, and that's where you would get the 1.2 ohms. Maybe you didn't make this error when you tried the question, but on tests and quizzes when doing parallel combinations, this is the most common calculation error I see for circuits. It's forgetting to take that last bit where you take the final thing to the power of -1. Right, back to the main problem. RA is 1.2 ohms, and I have drawn a new diagram here where I've substituted that RA in for R2 and R3. Looking at this next diagram, I think you can see here that R1 and RA are connected in series. We can now replace these two resistors with one final resistor, Req, by directly adding R1 and RA. So R1 plus RA is going to give us 1 ohm plus 1.2 ohms for a final value of 2.2 ohms. This is our final equivalent resistance. Once I have this, I can just go back up to the top of the question and substitute in that Req is 2.2 ohms. Just to summarize, first we added R2 and R3 together in parallel to get a value for RA of 1.2 ohms. Next, I added R1 and RA together in series, which got me my final value of REQ to be 2.2 ohms. Now, as I said, you will be tempted to do all of this in one step. And in this case, it may have been feasible to do that. But please try and resist that temptation, because as we get to more complicated combinations, it's better to try and break it down into smaller steps. It'll just work out better for you in the long run. All right, that brings us to the end of the video. I'd like to thank you for watching and hope you have a great day.